Okay, so this is the class about inferential statistics. And we will focus on how to operate these four testing methods, including t-test, chi-square, Pearson's R, and ANOVA. And we will using R, a statistical tool. So now we will first install R on your computer. And if you already have installed before, you can skip to next section. And here is a link, or you can just type R on searching engine. And when you click it, here is the home page on R. And we click the cram. Here is below download. And next, find the following URL, which nearest your location, and we can just choose 0 cloud. And in the middle, choose the version that fits your system. So let's choose for Windows. Then choose install for the first time, and click this download item, and wait for the download. And after that, find your download item and start installed. You can just choose the default and continue to the next. And you will see the interface in R. After you install your R, you can see the shortcut on your desk, and open it. You will get the interface like this, and we can start now. So first, open the new script below the file button. New script. Then you will get a new window called editor, where you can type your command and run directly. And here is the window. You can choose title horizontally or vertically. So before we start our testing, the first step is to import your data. And the command we use is called read the CSV. And you need to assign the name that you want to call in R. So let's say raw data is read the CSV. And inside, we have to tell R where we want to import and what is the name we are going to use in R. So here, file is, you need to type the path here, and you need to find the place that the data is and click it to show its content. So here is its path, and this is the file name and its file type. So now we need to copy this path and type in. Okay? And you need, here is some notation, is that the path here is only one black slash, and the command needs 2. So you need to add the file, you need to add one more black slash in each black slash. Let's choose horizontally. Black slash. And after the path, you need to type the file name and the file type. So the file name dot file type. Okay? And the last, you need to, because our data, the first row is the name of the variable, so your header is true. Alright, so now you can run the section. Here is a console that the output will show, and you now already read your data. Okay, so now we can check what data we have already imported. So you can use dimension row data to see it has 104 rows and 15 columns. Okay, and after that, the square bracket is the command which we can use to check assigned row and column we want. For example, row data, this square bracket, and the first is row, and the second is the column. So for example, if we want to see the first 5 rows, we can say 1, 2, 5, comma, and space, which means we want to see the data and the first 5 row data. So it will show the data which you just import for the 1 to 5, the first 5 row data. And for example, if we want to see the second column to the 5th column, that is the variable from mother education to 1, 2, 3, 4, 5 to get the will who wants to get higher education, then we can type row data, and also 1, 2, 5 row and 2 to 5 column, and the data you will get it. Okay, you can try your own. I will leave the comment here so that you can review when you need it. And the first, we are going to our section 1. The first is two sample t-test, and which we aim to compare if there is significant difference between two means from two given independent samples. So usually if there two variable is composed of one quantitative and one categorical data, and we can compare two means from quantitative variable by two groups, where from categorical variable. Well, there are some notes that we need to notice that when we use t-test. First is the population parameter is unknown, for example the means or the variance. And the second is the sample. The distribution should be approximately normal. So here is the command that you will use, and we should check if these two samples are approximately normal. We will use Sharp-Wilk test. And the variance, the second, the variance of two independent samples are the same or not, because it will influence the method we use to run t-test here. Okay, so, and the output, if the p-value is less than our significant level, usually we will assume it at 5% during our whole class. Then we reject the null hypothesis. That is, we reject these two samples are normal distributions or they have equal variance. Okay, so otherwise we will accept they are normal distributions and go on the next part. Okay, and now we will check if the two samples have equal variance. And similarly, if the p-value is less than 5%, then we reject these two samples have have equal variance. If more than 5%, we accept them have equal variance. And last, we will do t-test. In t-test, we will put two samples and type the alternative hypothesis of your test. The default is two-side tail test. And if your alternative hypothesis is left-tailed or right-tailed, if it's left-tailed, then you need to type less. If it's right-tailed, you need to type greater. Okay? And to see more descriptions of the command, you can type question mark plus command. Then you can see the default and other more detailed of the command. Okay, now let's see our example of the question. And the example, we wonder if there is a significant difference in average of G1 score based on gender. So null hypothesis is mu1 equal to mu2. And we conduct two tail tests of two sample t-tests. Okay, so the first, we will see the distribution of G1. So here, we will first read the data, which means we need to collect the data we just import at its gender is female, whose G1 score. Okay, and the male, we will assign it as the raw data, which gender is male, and we collect its G1 score, assign it as male. And after that, we will run it first. And after that, we will see the histogram. Look at its histogram. If it has a bell shape, so we will first cut the window in two columns here. Okay, and we will draw histogram first. So here is the histogram of G1 score, and we can see that it has a bell shape. And we want to have more information. We will usually know more QQ plot to see if the distribution of the sample is normal distributed. So here is the QQ plot and the QQ line of G1 score. And in QQ plot, you can see these are the sample quantity and the theoretical quantity. And how to interpret this plot is if they are approximately normal distributed, the sample quantities should fall on the straight line through first to third quantities. So you can see this part. Okay, so we guess the distribution of G1 scored will fit our assumption. So now we will use Shapiro-Wilk test to test if the sample is drawn from normal distributed population. So here we will conduct Shapiro-Wilk test. And here is the output. You can see the p-value is 0.07, around 7%. Which is more than 5%. That means we do not reject null hypothesis, and we means that the data is from normal distribution population. So here we do not reject null hypothesis, and this null hypothesis means the Shapiro-Wilk test's null hypothesis. Okay, so now we will next to check if they have equal variance. Okay, so first we will see the histogram of these two. Histogram of these two score, G1 score. Okay, so where is our here horizontal? Oh gosh, vertical. Here is histogram, and we can see that they seems to have the same shape. So we need to use f-test to see if the ratio of the variance from two samples are equal to 1. So now we will run variance test to conduct our t-test. Okay? Sorry, here. We will run, and here is the output of its f-test. You can see the p-value here is 50%, which is also greater and more than 5%. So we do not reject null hypothesis, which means we will use equivariance condition when conducting t-test. Okay, so now move on the next part. So the next we will conduct t-test to see if the two samples have significant difference in average of G1 score. And since we already have the test and we do not reject these two data has equivariance, so here your alternative is two-side tail test, and the variance equal here is false. Okay, we do not reject. Sorry, here is true. Okay, their equivariance is true. Okay, so we will conduct true. Alright, so here is the p-value. Okay, so we can say that since the p-value of the output here is less than our significant level 5%, thus we have evidence to reject null hypothesis, which means there exists a significant difference in an average of G1 score based on gender. So here I will write it here. So we have evidence to show there exists a significant difference in average of G1 score based on gender. Okay, so let's finish our two-sample t-test. Okay, there are some notations because I will introduce that if you want to see more descriptions, you can use a question mark and command. So here, for example, if we want to see t-test, you can just type question mark and t.test. It's command and enter. So it will output the default and the more detailed instructions of t-test. Okay, so now here is the default of t-test. So you can see that if you do not type anything, the alternative you should choose is two-side, less or greater, which is representative two-tail test, or left. Less means left-tailed, and greater means right-tailed. So the mu is set for 0, and the equivariance are false. So if your equivariance is true, you need to type T, okay? And the confidence level usually assume it is 0.95%. Okay. And here are more descriptions of the comments so that you can see if you have any question. Okay, so now let's move on the next part, our section 2. And in section 2, we are going to use a chi-square test for independence of two categorical variable here. And here are two notices we have to aware. First, when conducting chi-square tests, the expected and we will usually need to create a contingency table, and the expected the count in each cell of contingency table should be at least 5, which means if you are less than 5, you need to combine some columns or some rows to meet this condition. Okay, if you do not do these things, this correction, the chi-square approximation may be incorrect. And the second, if the contingency table is 2 by 2, which means your column and the row number are 2. If you use 2 by 2 contingency table, we will apply the continuity correction. And this command is shown below. Okay, and we will first create here. We will first create a contingency table by using this command names table. And after that, we will use the contingency of two variables to go to run our chi-square test. Okay, so now let's see our example here. We wonder if the current health status is related to quality with the quality of family relationships. Okay, so we will use a table command to create a contingency table of these two variables. Okay, so here first we need to use this table command, and we will read these two variables is the health and the family relationship. And the dimension name I will assign it as health of status and the family relationship here. And I will assign this table as S. Okay, so wrong. Okay, you can see what is the output of S. So here it will conduct the table and the contingency table for these two variables. And you can see that there are some small number observation which will cause the expected count less than 5. For example, here are so many zero, while this number are much more than here. Okay, so we will combine. Let's combine because it is ordinal data. Okay, so I will combine level 1 to level 3 and level 4 to level 5 for both two variables. Here is also, that means I will combine 1, 2, 3 here. You can see I will combine this table with this source cell. Okay, so here are some skills that I will first combine the row here. This command names row bind. Combine the row. Okay, so I will add first column, first row to third row, and the fourth row to fifth row. That is we combine row first. After that, I will combine the column. Okay, so we can see if I combine row first, and let's see y1. Okay, so I combine this row. Okay, 1, 2, 3 row. Okay, and the 4 to 5 row. And after that, I will combine y1 data from 1 to 3 column and fourth to fifth column. Okay, So after that, I will combine column bind, which means combines column and run. So you can see the Y. Oh, sorry. Y here. So I combine, which is the result of the 2 cross 2 contingency table. Okay, and I'll assign the new name Y. And since the contingency Y table is 2 cross 2 table, we will need to apply continuity correction when conducting chi-square test. So the final, just use chi-square test, and the contingency correction is true here. Okay, so run, and you can see the output here. It will do the continuity correction by Yetis. And the p-value here, the p-value here is greater than 5%. Okay, so we do not reject null hypothesis, which means we conduct that which means we conclude that we have no sufficient evidence to show that these two variables are independent. Okay, so we have no evidence to show that the current status and the quality of family relationship is independent. And that is our chi-square test. Okay, so in the third section, we will test if two quantitative variable has linear correlated by using Pearson's R correlation coefficient. And here we will also assume that these two variables should be approximately normal distributed. And besides, since Pearson's correction coefficient is highly affected by outlier, we should also check here. We should also check the outlier before conducting linear correlation test. And here is the command. We will use box plus. Okay, we will use box plus to see the distribution and see if there is this outlier. And we will plot use plot to see the scatter plot of these two variables, so we can see the trend of these two variables to see if it is linear correlated, and in that way the Pearson's R coefficient is suitable. And the final, we will use correlation test to check the Pearson's R. Okay, so now let's see our example. And it wants to see if there is a positive linear correlation between G1 score and G2 score of those students with frequency of going out friend less than rank 4, and which means we need to restrict the go out frequency less than 4. Okay, and separate it and to collect the G1 score and G2 score. Alright, so and since we want to check it is positively linear correlated, so the null hypothesis is the population rho will less than 0 or equal to 0. Okay, so before we start Pearson's correlation test, we check these two samples, G1 score with going out frequency less than 4 and the G2 respectively, and if they roughly normal distributed, and we will use QQ plot. Okay, so here okay, so we still need to first collect the data whose go out frequency is less than 4, whose G1 score we will name it G1 go, and collect the data whose go out frequency less than 4, it's layer G2 score. We will assign it as G2 go. Okay, so let's conduct it first. Oh, by the way, in R command, if you use this mark, it will ignore the word uh, next to them, so it won't conduct this file, okay, and this word, okay, wrong. Okay, now so you can check your G1 Go. Sorry, you can check your G1 Go. So this is the data you collected G1 score whose goal of frequency is less than 4, okay? So now we will draw the QQ plot of these two groups. Alright, so let's see its QQ plot. So now you can see okay, so now you can see the QQ plot shows the first to third quantitative here also are close to the line, okay, so we will now go on to check the Chaparral Wilk test here to see if they meet the normal distributed test, okay. So both these two p-value are greater than 5%, okay, so it exists our significant level, thus we will infer these two samples meets the assumption of normal distribution. So the next we can see if there exists outlier between these two groups, okay. So because we will need 3 figures, so I will color this window in 3 columns, and then we will plot box plot first. Alright, so you can see the first is G1 score whose goal of frequency is less than 4, and the second is G2 representative. And now you can see here exists one outlier not one, some outlier here. There exists some outlier here, but it's the most easy way to draw box plot and see if there is any single point located at two tail. But there are different definition and test for outlier. So we will check if their scatter plot has this outlier has influenced this scatter plot. So we will go on to plot these two variables, and here from here to here are the setting for the color, the size of the plot, and here this will assign the length of the x-axis, and here is the length of the y-axis. Okay, so now we can see their scatter plot is shown here, and you can see this outlier. Even though it is outlier, it still means the positive linear correlated. So we won't delete this outlier since it won't affect too much to our Pearson's R. Okay, so now we will go on to continue our test. Here is the correlation test, and since our null hypothesis is for left, here is right-tailed. Okay, it's right-tailed. So our alternative is greater. Okay, and our method is use Pearson. Alright, so we will conduct this command. And now we can see that Pearson's product moment correlation test. Here is the sample estimate, and the 0.9 is very high, highly positive correlated. Alright, and we can see the p-value is very small, which let us reject our null hypothesis, and means these two samples are positively linear correlated. Okay. Alright, so that is our Pearson's R. Okay, so in section 4, we are going to do one-way ANOVA, which can use to test the means of quantitative variable. Here, to test quantitative variables are the same among more than two independent groups, and if there are only two groups, we will back to use t-test. Okay, so here also has some assumption we need to know when use and interpret one-way ANOVA. First is the sample. Okay, so first the sample among groups should be drawn from normal distribution and with common variable. Okay, so the variance of population should be equal. And the third, which means that each samples has been drawn independently of the other samples. Okay, and if this assumption doesn't meet, and our ANOVA result may be unreliable. So you need to very carefully. And here are some comments listed below, which represented the first is ANOVA table. Okay, so the next we will still use a Chaparral Wilk test to check the normality. Okay, and the second is Bartlett test. Bartlett test is for equivariance, and the Durbin-Watson test here. Durbin-Watson test is used for the independent. And since it is a package, so we need to download its package. So now let's see our command. So first, our example is here. The example says that if there is a significant difference in average of G1 score among different current health status. Okay, so we can, since the current health status has 5 levels, and we can use LM command. Okay, here LM command to fit the model first, and we do the summary of the ANOVA table. So it will show the table here, and we can first, likewise, we need to assign its health is level 1, whose G1 score we will assign it as Y1, and whose health status is level 2, whose G1 score we assign it as Y2, and so on. So here are 5 labels, their G1 score. Okay, and I combine these 5 code G1, and we need to claim their factor is from health 1 to health 5. And since they don't have equal number, so we use length to correspond their number. Alright, so the health we will assign it as a factor of this number G1. Okay, so here is the command we need to construct our ANOVA data. Okay, so you can see G1. You can see G1 is the score ranked it by health 1 to health 5. Okay, and the represented factor is health. Okay, so to 1 to 5, like that. And now we will use linear model to fit their model, and the output we will assign it as LM output. Here you can see what is LM that output is. I'm sorry, here you can type output LM that output, and here is the result it has calculated. Okay, so now let's use summary to show the ANOVA table. So here is the ANOVA table that we can see, and here is the procedure and the sum of square of health and the procedure. Okay, and is there F value? So usually we will see the P value here. So the P value here is also it will greater than our alpha level is 5%, and hence we have no significant evidence to show that the average here from G1 to from the G1 score from health level 1 to health level 5 are not equal. Okay, but we did not do any test, right? We have said that you need to meet these 3 assumptions. Okay, so now let's do some check for the procedure. So first we need to test normality, and the normality is sharp row test, and usually we will see the QQ plot first. Okay, so here is the QQ plot for the procedure, and you can see from first to third quantile. Here, third quantile, it will approximately located along with the QQ line. So we will go on to conduct Sharp-Rowe Wilk test, and you can see the p-value is more than 5%, which means we do not reject the normality of procedure. Okay, so let's move on. The next is equivariance. If they have homogeneous among different groups, so we will use box plot to see the distribution between different groups of their G1 score. Okay, so here is the health condition from level 1 to level 5, their G1 score, and actually it seems to not have extremely difference among different groups, but still hard to tell by box plot. So we will use Bartlett test to check equivariance. Bartlett here, and we will run. So and you can see the p-value. Okay, so the p-value is over 50%, and we can show that we do not have evidence to reject null hypothesis. Namely, we do not reject these different health status has equivariance. Also, the last is the independence. Well, when we talk about independence, since we usually conduct ANOVA when dealing with data which collected from an experiment, so the independence should be confirmed when conducting experiment, right? But some independence of data from social study may hard to observe and control. So the method we use is Durbin-Watson test. And uh, if you are the first time to use, you need to here you need to install package. Okay, so you can let me check wrong. Okay, so you can use library LLM test. If you are not able to download, you can install here and choose the place that nearest to your location. So I choose Taiwan and find the LLM test package. So find LLM test. Where? LLM test. Here, LLM test, and just download it. Okay, but since I already download it, so it may be okay. So after that, you can just type library, or you can use here to load the package. Okay, so that means you can use DW test, Durbin Watson test. Okay, so now let's check DW test. And here is the output. You can also see the p-value of the Durbin Watson test is more than 5%, which means it has no evidence shows that uh, we that we do not reject null hypothesis since there is no evidence that the procedure is correlated. All right. So here are all ANOVA tests, and sometimes if these three assumptions cannot meet your standard, you need to consider other method, some non-parametric method. Okay, so sometimes if the assumption did not apply, your result of ANOVA cannot be reliable. Okay, thank you.